In the previous class, we have done parabola, few things about like focus, what is the focus, what is the locus of the parabola, or parabola is the locus of which point, I should say. And then we did the focal distance of the parabola, latus rectum. We have done all those things. We also studied all these four parabolas, upward opening, downside opening, left opening, right opening, and all the things about them. There, what is their focus, what is their directrix. All right. So then we have done these few questions over it. Then another question, and then parametric coordinates. Like for y square equals to 4ax, parametric coordinates were 80 square 280. For y square equals to minus 4ax, parametric coordinates were minus 80 square minus 280. Whereas for x square equals to 4ay, parametric coordinates will be 280 comma 80 square. All right. So this was a simple thing we have done. Then we did this. Then we came to chord of a parabola. So equation of the chord joining 2 points 81 square comma 281 and 82 square 282. I told you very like particularly one thing you need to remember is the slope of this chord. Another thing you need to remember is the equation of this chord. Equation of the chord is t1 plus t2 into y equals to 2x plus 2a t1 t2. This just came from the equation of line in 2-point form. Y minus y1 is y2 minus y1 upon x2 minus x1 into x minus x1. All right. Now, if this is a focal chord, if this chord is passing through the focus, if this is a focal chord, it will pass through a comma 0. So chord passing through a comma 0 means t1 t2 equals to minus 1. Am I clear? If this chord is passing through the focus, then t1 t2 is equals to minus 1. That means now if any time if I had to assume the ends of a focal chord, I don't have to use two parameters. If one parameter is t, then parameter of the another end of the focal chord is minus 1 by t. So if one coordinate will be 80 square comma 280, another coordinate will be a upon t square minus 2a upon t. Am I clear? Then we have done like if there is a chord AB, if this chord is obtaining angle 90° at the vertex, means origin in this case, then T1, T2 goes minus 4. All right. And then I taught you how to get the length of the focal chord. So length of the focal chord in terms of T is, if the ends of the focal chord are AT1 square 2AT1, other end will be A upon T1 square minus 2A by T1. Now I particularly told you, don't find the length of the focal chord using this formula. Got it? Don't find the length of the focal chord using this formula. Find the length of the focal chord using AS plus BS. Now AS is what? That is A plus AT1 square. BS is what? A plus A by T1 square. Now simply it is A times T1 plus 1 by T1 whole square. Now see what few things come from this. This is what we have already covered. Now see, there is a property of the focal chord. Length of the focal chord is what I have already covered. This PQ is A times T plus 1 by T whole square. Got it? Length of the focal chord in terms of the angle. Now let's somehow they are saying PQ is a focal chord whose inclination is theta. PQ is a focal chord whose inclination is theta. Now, what is tan theta? Tan theta is 2 upon T1 plus T2. You remember this thing? Now, in case of parabola, another parameter is what? 2 upon T1 plus 1 was T upon T1 minus 1 by T1. So it is 2T1 upon T1 square minus 1. 2T1 upon T1 square minus 1. Now this is what? This is my tan theta. So I will write it this way, that T minus 1 by T is 2 cot theta. Got it? So t minus 1 by t whole square is what? 4 cot square theta. Now add 4 to the both sides. The moment you add to the both sides, this becomes what? This is t plus 1 by t whole square. T plus 1 by t whole square is 4 cosec square theta. That means this PQ length is what? It is 4a cosec square theta, where theta is the inclination of the focal chord. Theta is the inclination of the focal chord. Got it? Now, very, very important point. Semilatus rectum. Semilatus rectum of a parabola is the harmonic mean between segments of the focal chord. See, let us assume this is parabola y square equals to 4ax. Now, what they mean? Semilatus rectum. See, latus rectum is 4a. So, semilatus rectum is what? 2a. That means the meaning of this word, is 2a. So, semilatus rectum of the parabola is the harmonic mean between the segments of the focal chord. So, if let us assume focus is S. So, what they are saying, harmonic mean means 1 by PS plus 1 by QS is 2 by 2a. That is 1 by PS plus 1 by QS. This is 1 upon a. Semilatus rectum is the harmonic mean between the segments of the focal chord. Am I clear? Now see, say this point P is at square 2at. Then this point Q will be a by t square minus 2a upon t. Now tell me this PS. PS is what? PS is equals to PM. Now this is a, this is at squared. So PS is what? A plus at squared. Got it? Now what is QS? QS is this length. So QS is A plus A upon T square. So 1 by PS plus 1 by QS is what? Better. 1 by PS plus 1 by QS is what? 1 upon A plus AT square plus here if I take LCM T square upon A plus AT square. So it is 1 plus T square divided by A into 1 plus T square. Now this is cancelled. So if this is cancelled, I got 1 by A. Got it? To which I can write 2 by 2a. So very important point that semilatus rectum is the harmonic mean between the segments of the focal chord. Got it? Now let's do 2 or 3 questions over these properties. Just a moment. Now, let's do a question. In a parabola, y square equals to 4ax, or let me take it y square equals to 8x. In a parabola, y square equals to 8x, PSQ is a focal chord. PSQ is a focal chord, and given that PS is say 7, find the length QS where S is focus. Yes, do it. How do I do it? Give it a try quickly. Just, just use the property which I told you right now. Segments of the focal chord have semi-latus rectum as harmonic mean. That means what? 1 by PS plus 1 by QS is 1 by A. Now, according to this parabola, if I compare it, y square equals to 4ax, your A is what? 2. Got it? So 1 by 7 plus 1 by QS is 1 by 2. So 1 by QS is what? 1 by 2 minus 1 by 7. So it is 5 by 14. So QS is what? 14 upon 5. QS is 14 upon 5. Simple question. Now let's do another question. Say there is a parabola. Now the question is AB is a chord of the parabola. A circle of radius R is drawn taking AB as diameter and it is touching x-axis. AB is a chord of the parabola. A circle of radius R is drawn taking AB as diameter and it is touching x-axis. Find the slope of chord AB. Yes. And definitely your parabola given to you is y square equals to 4ax. Just give it a try. First of all, before like starting for a solution, draw a very neat and clean diagram. Very, very neat and clean. Got it? So see, this is the parabola we have. Now there is a chord AB like this. There is a chord AB. Now a circle is drawn keeping this chord as diameter. This is something like this. AB as its diameter. Now it is not a focal chord, so don't take T2 as 1 by T1. If vertex A is A T1 square 2A T1 and vertex B is A T2 square 2A T2, what will be the coordinates of the center? Coordinates of center will be A T1 square plus A T2 square by 2, comma A times T1 plus T2. Am I correct? Now also one more thing. Since it is touching y-axis, sorry, it is touching axis of the parabola, or I should say x-axis. So y coordinate of the center will be equal to radius of the circle. They are saying radius of circle is r. So radius is a upon t1 plus t2. Got it? Now they are asking for slope of the chord. Just I started today's lecture with the slope of the chord. Slope of the chord joining T1 and T2 is m equals to 2 upon T1 plus T2. Got it? So 1 upon T1 plus T2 is what? R upon A. So 2 divided by R by A. So it is 2A upon R. Now if it is, say if I take R positive, it will be like above the x-axis. Now there can be a chord exactly below the x-axis. There can be a chord exactly below the r-axis. In that case, slope can be 2a by minus r. Am I clear? So that means slope can be 2a upon r, comma minus 2a upon r. These are your two answers. Fine. Dhruvi, understood? So this is how we get the slope of this chord. This is a question from J Advanced 2014, I guess, 14 or 15. Now, let's do a very important and a good topic. See, this is a parabola. Now, this is its focal chord. This is the directrix x equals to minus a. And the property is, if a circle is drawn taking focal chord as its diameter, if a circle is drawn taking focal chord as its diameter, it will touch the directrix. The property is, if a circle is drawn taking focal chord as a diameter, it will touch the directrix. If a circle is drawn taking focal chord as its diameter, it will touch the directrix. Now, how do you get it? See, this is the point at1 square to at, or I should take t only, not at1. So this is the point at square to at. So this point B will be a upon t square minus 2a upon t. Now the midpoint of this chord will be what? This is the center of the circle. Center of the circle is a t square plus a upon t square by 2, comma 2a times t minus 1 by t upon 2. Yes or no? Now, what is the distance of its center from the directrix? Distance between center and directrix. Distance between center and directrix will be what? A plus at square plus a upon t square by 2. So if I take a by 2 common, it is t square plus 1 by t square plus 2. So if I take a by 2 common, it is t plus 1 by t whole square. And if you remember, this is the length of the focal chord. This is the length of the focal chord. Here it is. A times t plus 1 by t whole square. That means half of this is the radius of the circle. So means what? This is basically radius of this circle. Got it? Now, if center is exactly at a distance of radius from this line, that means it is touching that line. Because if it is not the tangent, if it is any chord, this perpendicular distance should have been less than the radius. Got it? So that is why it is the radius of the circle. and that is why this circle is touching the directrix. Am I clear? Very important property. Now, position of a line with respect to a parabola. Now see, this is a parabola given to you, y square equal to 4ax. This is a line given to you, y equals to mx plus c. So, if I solve them, solve line and parabola. If you solve both of them, see what exactly could have happened. This parabola might intersect this line at two distinct points. In that case, this line will be the chord of the parabola. This line can touch the parabola, which is the case of tangent to the parabola. This line may pass outside the parabola, which is the case like neither touching nor intersecting. So this line has nothing to do with parabola. It is just passing outside it. So what do? We just solve these things. So I'm just placing y equal to mx plus c in the parabola. So it will be mx plus c whole square is 4ax. So it is m square x square plus c square plus 2mcx is 4ax. Got it? So it is m square x square plus 2x into mc minus a plus c square equals to 0. M square x square plus 2x into mc minus a plus c square equal to 0. Now there are three cases. First case, line is chord. And I call this case as first case. In that case, this quadratic will be having two distinct real roots. So its d should be more than 0. That means 4 times mc minus a whole square minus 4m square c square more than 0. So 4 cancel. If you simplify it, m square c square plus a square minus 2a mc minus m square c square more than 0. This m square c square cancel. So you got it as some mistake has happened. D more than 0 means more than 0 b square. So 4 times mc minus a whole square minus of 4m square c square. Okay, it is mc minus 2a. That's what I'm saying. There is a mistake. So mc minus 2a whole square. So what it will become? M square c square plus 4a square minus 4amc minus m square c square more than 0. They are cancelled. Now you get a minus mc greater than 0. So this is the condition for which this line is a chord of the parabola. Am I clear? Now, if this is the second case when line is tangent, so I call this as second case. So if line is tangent, that means what? These two equations will be having two equal roots. Because there is a point of contact, this equation will be having equal roots. So its d you will make it 0. That means a minus mc equal to 0. So the value of c will be a by m. Got it? And if it is a third case, like line is passing outside the parabola, it is neither touching nor intersecting the parabola. In that case, this d will be less than 0. And if you simplify it, you get a minus mc less than 0. A minus mc less than 0. Am I correct? Now, so these are the cases for. That means if y equals to mx plus c is a tangent to the parabola, y square equals to 4ax, then C will be what? C will be A by M. Or I should say tangent will be y equals to mx plus A upon M. Just have a look. I'll be back in a minute. This is a tangent in slope form. Tangent in slope form. If somebody asks you for the parabola y square equals to 8x, write tangent with slope as 1 by 2. So tangent will be what? Mx. 1 by 2x plus A. A is what? 2. And M is what? 1 by 2. So y equals to x by 2 plus 4. Y is equal to x by 2 plus 4. Got it? So this condition of tangency I just told you, this is y equals to mx plus A by M is equation of tangent. And in this case, C is A by M is condition of tangency. Got it? Now equation of tangent to this parabola in different situations. So first is point form. Now let us assume there is a point x1 by 1 on the parabola. Parabola is y square equal to 4ax. There is a point x1 by 1 on it. So I told you the equation of tangent can always be obtained on any conic by replacing x square by xx1, y square by y1, x is x plus x1 by 2, y is y plus y1 by 2, and keep constant as it is. Got it? So now since it is y square equals to 4ax, so to tangent at x1 by 1, this x1 by 1 should be on the conic. It should not be somewhere inside the conic or outside the conic. It should be on the conic. So it is y by 1 is 4a times x plus x1 upon 2. So y by 1 is 2a times x plus x1. Y by 1 is 2a times x plus x1. This is the equation of tangent in point form. Am I clear? Now transformations to get tangent. See, if we have a parabola y minus 2 whole square is 4a times x minus 1. Got it? Y minus 2 whole square is 4a times x minus 1. So what do? We replace y minus 2 as capital Y, x minus 1 as capital X. So we will do y square equals to 4ax. Got it? We will do y square equals to 4ax. Now write the tangent in this form and then finally substitute capital X and capital Y from here in terms of small x and small y. I'll teach you about this while we go through these points in some questions. Now parametric point. There comes the most important definition of tangent. See, on the parabola y square equals to 4x, there is a point 80 square 280. On the parabola y square equals to 4ax, there is a point 80 square comma 280. So what is the equation of tangent? In point form, tangent is y1 equals to 2a times x plus x1. Now replace y1 as 280 and x1 as 80 square. So 280 into y equals to 2a times x plus a t square. This 2a cancelled. So it is ty is x plus a t square. Very important thing to remember. This is the equation of tangent in parametric form. Ty is equals to x plus a t square. That means equation of tangent at this point. Got it? So equation of tangent at a t square comma 280 is ty equals to x plus a t square. Now equation of tangent of slope m of the parabola. Equation of tangent of slope m. This is what I have already told you. This is y equals to mx plus a by m. Now see, let's learn something from here. At the point 80 square comma 280, you have tangent as ty is x plus 80 square. Now I divide it by t. So you get 1 by t into x plus 80. Divided this equation by t. 1 by tx plus 80. Now do one thing. Replace this 1 by t as m. So y equals to mx plus a upon m. Y equals to mx plus a upon m. Got it? Y is equals to mx plus a by m. Now see, these two equations are correlated. Same. That means this from its point of contact can also be obtained using this same substitution. So its point of contact will be a by m square 2a by m. Its point of contact will be a by m square point of contact is a by m square 2a upon m. Got it? Now, relation between slope and parameter, I just explained it to you. Relation between slope and parametric form. So if the tangent is y equals to mx plus a by m, its point of contact is a by m square 2a by m. If the tangent is ty equals to x plus 80 square, its point of contact is 80 square comma 280. Got it? Now point of contact. Now let's do a question. How do we get the point of contact? Say there's a question for the parabola. For the parabola y square equals to say 6x. For the parabola y square equals to 6x. Find the tangent of slope 2 and then find its point of contact. And then find its point of contact. For the parabola y square equals to 6x, find the tangent of slope 2 and then find its point of contact. See, this parabola is assumed as 4. A will be 3 by 2 into x. So this 3 by 2 is what? This is your A. Y square equals to 4. 3 by 2 is A into x. Y square equals to 4ax. Now, slope 2 tangent will be y equals to mx 2x plus a is 3 by 2 into m. A by m and m is also what? 2. So it is y equals to 2x plus 3 by 4. So it is 4y equals to 8x plus 3. So this is 8x minus 4y plus 3 equals to 0. 8x minus 4y plus 3 equals to 0. Got it? Now you want to find its point of contact. Now there are two ways to find the point of contact. If you remember that in slow form of the parabola, point of contact is a upon m squared to a upon l. If you remember that a upon m squared to a upon m. So the point of contact will be what? 3 by 2 m square is 4 into 2 3 by 2 into m is what? 2. So it is 3 upon 8 into this 2 to cancel 3 by 2. This is one way to get the point of contact. All right. Now, how do we get the other way? See, let us assume the point of contact be x1, y1. In the same question, let point of contact is x1 comma y1. Now equation of tangent is what? y1 is y1 is equals to 3 times x plus x1. So it is 3x minus y1 plus 3x1 equals to 0. You just compare these two lines. Now this line is 8x minus 4y plus 3 equal to 0. If I compare it, 3 by 8 is y1 upon 4 is 3x1 upon 3. This is cancelled. So x1 is what? X1 is 3 by 8. If I equate these two, and if I equate these two, y1 will be 3 upon 2. So point of contact is 3 by 8 comma 3 by 2. Point of contact is 3 by 8 comma 3 by 2. Got it? So this is how we get the equation of tangent. Now see, you need to find the tangent of this parabola. Again, what did I tell you? Replace y minus y1 as capital Y and x minus x1 as capital X. So the parabola you got as y square equals to 4ax. Tangent to this is y equals to mx plus a by m. So y minus y1 is m times x minus x1 plus a upon m. Y minus y1 is m times x minus x1 plus a upon m. So this is the equation of tangent. If you don't have a standard parabola, if we have a say I should say shifted parabola where origin has been shifted from 0, 0 to x1 comma y1. Got it? Now, point of intersection, again a very important point. See, this is a chapter where there are so many things to remember. So you just cannot ignore things and see that yes, I will drive it in the exam. No, you cannot do it. Everything cannot be derived in the exams. So many things are there which you can remember. Like you must remember that ends of a focal chord have parametric relation as T1, T2 equals to -1. You should know the length of the focal chord is A times T plus 1 by T whole square. You should remember that the equation of chord joining T1, T2 is T1 plus T2 into Y equals to 2x plus 2a T1, T2. You also should remember that the slope form of tangent is y equal to mx plus a by m. Condition of tangency is c equals to a by m. Equation of tangent in parametric form, their point of contacts, their properties like segments of the focal chord has harmonic mean as semi-lateral in between them. So these are so many properties that you have to remember. They are directly asked in exams. So if you remember them, it will be very easy to carry on. If you don't remember them, then stay lost in the exams. Getting my point? So take care of these things. that yes, if we remember it, it will be convenient and fruitful for us in the exams. Undoubtedly, it's a subject to understand, it's a subject to prove on your own, you prove it. But better you remember it also. Got it? Now, tangent to this, at this, say, now there is a point P that is a T1 square 2a T1. There is a point Q that is a T2 square 2a T2. Now, this point R will be what? This is a T1 T2, comma a T1 plus T2. Now, this is what? This is geometric mean of x coordinates, and a T1 T2, this is arithmetic mean of y coordinates. Geometric mean of x coordinates, arithmetic mean of y coordinates. Understood? So this is also something very important to remember. Now see, there is also a property. Now this is a parabola. You make it, you take 3 points on this A, B, C. Now you draw 3 tangents at these 3 points. Got it? So 3 points outside here also. So this is ABC, this is PQR. So there are 3 points on the parabola A, B, and C. Now you have drawn 3 tangents to these 3 points on the parabola, and you make a triangle outside the parabola, sorry, which is PQR. Now there are few points. First is area of triangle PQR is half of area of triangle ABC. Always. Area of triangle PQR is half of area of triangle ABC. Got it? Second point. Orthocenter of triangle PQR lies on directrix. Orthocenter of this external triangle PQR, it will always lie on directrix. Third point, circumcircle of triangle PQR pass through the focus of the parabola. PQR triangle is circumcircle will pass through the focus of the parabola. Like this particular one, it has been asked in JE 2 times. They took any random, and see, this is valid for any random parabola. Not only valid for y square equal to 4ax, valid for any parabola. Got it? So that is why this question is very prominent. This is the oblique parabola, tilted parabola, however it is. Because it is related to the distances and areas. It is not related to the coordinates of the points. Am I clear? So this is valid for any random parabola. Fair enough? Now, equation of normal to a parabola. See, normal, I also told you in the circle. Normal is any line which is perpendicular to the parabola, which is perpendicular to the tangent at the point of contact. Got it? So in the point form, we don't generally remember the equation of normal. If it is a point form, you just get the equation of tangent, write a line which is perpendicular to the tangent passing through the point of contact, you get the normal. First case. Now, in parametric form, in parametric form, tangent is what? Tangent is ty equals to x plus at square. Now, line perpendicular to tangent is what? Line perpendicular to tangent is what? Tx plus y is 2at plus at cube. Line perpendicular to tangent is what? Tx plus y equals to 2at plus at cube. Or see, let me drive it for you. Is lambda. Now make it pass through at square 2at. So lambda will be what? At cube plus 2at. So equation of normal is T x plus y is equals to 2at plus at cube. Equation of tangent normal is Tx plus y is 2at plus at cube. Now equation in slow form. Equation of normal in slow form. See, this tangent can be written as y equals to minus Tx plus 2at plus at cube. Slow form means y equal to mx plus c form. Now replace minus t as m. So y equals to mx minus 2am minus am cube. This is the equation of normal in slow form, and its point of contact will be am square minus 2am. Got it? Now before concluding this class, I leave something up to you. If normal at point T1 to the parabola y square equals to 4ax, meet it again at T2. So what you need to do, you know the equation of normal in at square 2at. You know the equation of normal as Tx plus y is 2at plus at cube. Now they are saying it is also passing through a point. It is meeting the parabola again at T2. So make it pass through 8at square 2at2. Then directly T2 you can obtain from this. T2 is minus T1 minus 2 by T1. I leave this proof for you. Got it? We don't have enough time. Still, we are trying to get through it as much as we can. So the only way is now you have to practice more questions on your own. All right. That will be all from my side. Thank you.